let's talk about chain rule. What is chain rule? Now this is chain rule. Okay, dy over dx equals dy over du times du over dx. This is chain rule. But this chain rule can derive different differentiation formulas when y equals different type of functions. For example, if y equals to the power of n, so in this case u is fx, y equals u to the power of n. Then dy over dx equals dy over du multiplied by du over dx. And then dy can be written as du to the power of n with respect to u, and then derivative of u with respect to x. So when we differentiate u to the power of n with respect to u, of course it's n times u to the power of n minus 1. And then u itself is fx, derivative of fx with respect to x. That is why we can also write dy dx as n times u is fx. So n now become n times fx to the power of n minus 1. And then this derivative of fx we can write as I prime x. That is why we also call this as chain rule. And this is a chain rule used when function is y equals fx to the power of n. So when you have the case like y equals 2x plus 1 to the power of 3, or when you need to differentiate square root of 2x plus 1 means 2x plus 1 to the power of half. Okay, or you have 1 over square root of 2x plus 1 means it is 2x plus 1 to the power of negative half. Whenever it's in the form of fx, this chain rule. Okay, let's talk about another case. If y equals e to the power of fx, so that's another type of function. This is exponential function. So once again, let's say u equals fx. Then y equals e to the power of u, right? We can replace fx by the variable u. Then dy over dx is once again dy over du, du over dx. And that means it is the derivative of e to the power of u with respect to u multiply the derivative of u with respect to x. Derivative of e to the power of u with respect to u is just itself e to the power of u multiplied by du over dx. And that is why dy dx can be written as e to the power of u, same as fx, so we write x. The derivative of u means the derivative of fx. So we can write fx prime. That's why this formula is also derived from chain rule. Now, last one, let's look at trigo function. For example, y equals tangent x. Then the dy dx will be secant. So what if y equals tangent? Now, if y equals tangent fx, okay, we can write u is fx. So y can be written as tangent u. Okay, if that's the case, dy over dx, dy over du multiplied by du over dx. So we have the derivative of tangent u with respect to u times the derivative of u with respect to x. So by applying the formula here, you differentiate tangent x, you get secant x squared. You differentiate tangent u, you should get secant squared u multiplied by the derivative of u, where that is the derivative of fx again. That is why you will have secant squared fx prime x. So here we have two columns here, simple rule and chain rule. So you can see what on the left hand side is always just about x, right? X to the power of n, sin x, cosine x, tangent x, e to x. So these are the simple rules. And then here is the chain rule. So what's inside is fx is fx to the power of n, sin fx, cosine fx, tangent fx, e to the power of fx. Derivatives, you can also see something in common. X to the power of n, when you differentiate, you get nx to the power of n minus 1. Fx to the power of n, when you differentiate, you get nfx to the power of n minus 1. Looks like the same, just with one extra thing. You multiply f prime x. Similarly, sin fx, when you differentiate, you get cosine fx, just like you differentiate sin x, you get cosine x. But this time, sin fx, when you differentiate, you get cosine fx multiplied by f prime x. Cosine fx, if you differentiate, you get negative sin fx f prime x. Now let's look at the question. Let's say I need to differentiate this y equals sin 5 minus x to the power of 4. So firstly, you will see the structure of this function is in the form of fx to the power of 4. That means n equals 4, fx equals sin 5 minus 2x. That's why in order to do this, you must use that formula on this one, fx to the power of n. When you differentiate, you get nfx to the power of n minus 1 times f prime x. That's why, look at here, it is n, which is 4 minus 2x to the power of n minus 1 multiplied by f prime x. And after that, you need to differentiate this sin 5 minus 2x. Now this time the formula is a little bit different. This time we use that formula. In order to differentiate sin 5 minus 2x, this one, sin fx, derivative is cosine fx f prime x. That's why sin fx, the derivative is cosine fx multiplied by fx derivative. So this time you differentiate what's inside the bracket, 5 minus 2x. Okay, the derivative of 5 minus 2x is just negative 2. So negative 2 times negative 4, negative 8. The final answer is negative 8 sin 5 minus 2x to the power of 3 and cosine 5 minus 2x. In summary, when we come to use the chain rule, we always multiply the derivative inside the bracket. Okay, we multiply the derivative inside the bracket. Sin 5 minus 2x is in the bracket. That's why we differentiate sin 5 minus 2x. Later, when we differentiate this sin 5 minus 2x, the 5 minus 2x is in the bracket. So we once again differentiate 5 minus 2x. And you have to always take notice of the structure of the function. At the beginning, the function is in the form of fx to the power of 4. That's why you use the formula nfx to the power of n minus 1 f prime. Later, when you differentiate sin 5 minus 2x, that is a form of sin fx. So you have to use cosine fx f prime x. This one is a bit messy. Okay, so differentiate fx derivative because it's the format of sin fx. Okay, so that's basically what we should have to do.